spinning up servers for every tiny idea? Forget that! With serverless, you just write the code and it runs. Voila! That's the magic! New to cloud or tired of setting up servers just to test your quick ideas? If that is the case, this video is for you. And in this video, I'm going to break down the serverless computing in plain English, reveal some real-life examples, and show you a demo that might blow your mind. Stick around till the end of this video, and I'm really confident that you will walk away with knowing how exactly the serverless computing works and how to use it. Let's get started. Think of traditional servers like cooking your own meal. You buy the ingredients, you prep, cook, and clean. With serverless, it's like ordering from Uber Eats. You just eat and someone else handles the rest. In technical terms, serverless means you focus on writing your code, function or a logic, and the cloud provider manages the rest. Scaling, maintenance, uptime. You pay for only what you use. No idle cost, no wasting of resources. Let's look at a real-world serverless event-driven use case. I had a requirement wherein when an application goes down, it should automatically create a ServiceNow incident, no manual steps. This is how we built it. When the app goes down, it sends a message to the OCI notification service topic. That topic triggers a serverless function, an OCI function, which is subscribed to it. As soon as the message arrives, the function gets invoked. It parses the payload and calls the ServiceNow API to create an incident, including details like application name, error description, timestamp, and other details. All this happens in just real time and is an example of event-driven automation. You can use a serverless function for scheduled task automation to back up your on-prem database to cloud nightly or at fixed intervals without maintaining a server 24/7. Serverless functions are very well suited for running your microservices application. You focus on your logic and the underlying platform manages your infrastructure, scaling, and execution in response to real-time events or user interactions. A common real-time file processing use case is generating an image thumbnail. When a user uploads an image, an event is sent to the Azure Event Hub, for example. This triggers an Azure function which processes the image and generates an image thumbnail in real time without a need of a server 24/7. An e-commerce company wanted to track and analyze the user behavior in real time. Serverless computing is a great option which makes the job easier and simple. Every click, view, and interaction is captured by the website and sends an event to the Azure Event Hub, for example. This triggers an Azure function which parses and enriches the data with additional information such as the user metadata, timestamp, and so on and so forth. The transformed data is pushed to the downstream systems such as the Azure Data Lake or Cosmos DB for analytics, real-time dashboards, and querying. There are a countless number of use cases where serverless computing can be applied. Taking time into consideration, I'm going to wrap up this section here. If you have any interesting use cases in your mind, please drop it in the comments below. I would love to hear it. Serverless computing is powerful, but it is not always the right fit. Take the long-running task like video transcoding. Most serverless platforms have time limits, so they may not fit here. If you have a consistent workload and requires high throughput, serverless can actually be more expensive compared to the reserve compute options. And remember, serverless functions are stateless. They do not retain data between calls. If you are trying to orchestrate multiple functions with retries and rollbacks, things can become really complex and hard to manage. Need GPU access or specialized hardware? Serverless doesn't support it. And finally, if you are in a highly regulated industry, the limited control over the environment may not meet the strict compliance or security standards. Before we begin, make sure you have an active Azure subscription so you can follow along with me. Open up your browser and head over to the Azure portal, portal.azure.com, and I'm currently in the Azure portal. Go to the search bar and type in the function app. We need to create a function app in Azure. So click on the create button. Azure lets you choose from different types of function app hosting options, from container apps environment to managing app services, and lots and lots and lots. So for this demo, we will go with the app service since we are hosting a very simple Hello World API. I am going to choose the app service and click on the select button. We need to fill in lots of details in this form, and I am going to explain whatever is relevant for this demo, and the rest I am going to set it to default or disable it. Okay, so let me just select the resource group. We need to provide our function app name a unique name because that will be used in our domain name. When we have to access our function, we will have to go through this FQDN, and your function app name is part of the FQDN. I'm going to give my channel name serverless demo. So Codify with Subbu is my channel, serverless demo, and this would be the complete FQDN. So this I will show you when our function app is created. We would need to provide the runtime stack. So in our case, we are going to use Python, and I'm going to leave the rest default. I'm going to change this to basic since this is only awesome. We have reached the last screen of creating our function app, and I'm going to click on the create button. This is going to take a couple of minutes. I'm going to pause this video and we'll come back once the function app is created. We have now successfully created our Azure function app, and it's time to add our actual hello world function inside it. I am currently inside the home page of our function app. Let's click on the create button beneath the functions to create our hello world function. There are a lot of templates that we could use to create our function. Since we want to expose this as a web request, web API, we will select the HTTP trigger option. This will allow us to run our function through a simple web request. Let me select the HTTP trigger and click next. We need to provide a function name. I'm going to give it as hello world, and I'm going to give the authorization level as anonymous for the purpose of demo. Let me click on the create button. This happens for the first time when the function is created. I just click on the refresh to make sure the actual Python code is loaded. So Azure now gives us a ready to use Python function to get started. I am going to tweak the response a little bit to return a very simple custom message just to show how easy it is to personalize the output. So I'm just going to change this string as this response generated for YouTube demo, and I'm going to place this in the else case as well. Okay, so now let's save this. Now the next step is how do we access this web API. So click on the get function URL and just copy this. This is the one that you need to copy it. Just head back to the browser and just paste it. So this will give us the response, this response generated for YouTube demo. So this URL comprises of three components. The FQDN was constructed while we generated the Azure app, and the next component is the API, and finally we need to say this is an hello world API. Pretty much that's what we need to do, and we got the response. This is a very simple implementation showing how a web API can be hosted on a serverless platform. You could extend this for different use cases. So if you're just getting started or tired of maintaining the infrastructure, serverless might just change the way you build. This is just the beginning. Like this video and subscribe to this channel and stick around. There's a lot more coming to help you simplify the cloud. See you.